Okay, so in our immune system, if we're going through uh, the resources that are available on the McGraw-Hill site, we can see that there are a number of vessels throughout the body that are the second set of vessels in addition to our cardiovascular vessels. And we refer to these as the lymphatic vessels. And they're going to cover all parts of the body, but there are heavier concentrations in the torso than what we see in the appendages. Now, throughout all of these vessels of the lymphatic system, we see very small lymph nodes. And lymph nodes are quite plentiful throughout our body, but we have a whole lot of lymph nodes in the axillary regions, that's the armpit regions, in the inguinal regions, that's the creases of our groin, okay, in the abdominal region, okay, we also have some in the cervical region, that's our neck region, and those lymph nodes are going to be important because they act like filters. They filter the lymph as it passes from point A to point B, going through the lymph nodes. And ultimately, if there are pathogens, they get trapped in these lymph nodes. Now, other major structures associated with the lymphatic system are the tonsils. The tonsils are going to guard our oral passageway and make sure that nothing that we inhale through the nasopharynx or that we take in through the oropharynx gets into our respiratory passageways. We also have the adenoids, which are towards the back and the roof of the pharynx, which is our throat, and they too are going to guard against any kind of pathogens that might get into our body through the oral cavity. We have the thymus gland, and the thymus gland is quite unique. It's going to be found in the thoracic cavity, and the thymus gland is going to be at its largest during our earliest years, and as we mature, it will actually get smaller, and it will actually be completely gone by the time we're an adult. And the thymus gland is going to secrete hormones which cause lymphocytes to mature and become T lymphocytes. All lymphocytes are going to originate in the bloodstream, or excuse me, in the bone marrow, and once they are basically destined by their genetics to be a T lymphocyte, then they'll migrate to the thymus gland, and that's where they become immunocompetent, as it's called. And the thymus gland, like I said, is going to be at its greatest size, creating the most T lymphocytes during its earliest stages of development. Other major structures of the lymphatic system include the spleen. The spleen is going to take out worn out red blood cells. Okay, but it also has a large amount of lymphatic tissue that is also going to be important in protecting us from pathogens. Now, if we look at figure 2.2 in the McGraw-Hill resource, we see vessels of the cardiovascular system, where we see arterioles and venules, and interwoven within those vessels of the cardiovascular system, mostly in the capillaries created between the arterioles and the venules, we see lymphatic vessels. And so the lymphatic vessels pick up fluid that isn't picked up by the cardiovascular system. And so anything that seeps out of the cardiovascular system would be picked up by the lymphatic vessels, and in turn, it's going to be filtered, but ultimately that fluid gets returned to the cardiovascular system. Now, some of the common terms that we will see associated with the lymphatic system: allergen, okay, gen is to produce, okay, al is different or strange, okay? And we typically think of an allergen, okay, and then erg, I should say, is work. It's a substance which creates an allergic response. An allergen is a substance which creates an allergic response. Household dust may not do anything to me, but some people might have quite an anaphylactic episode if they are very allergic to household dust. Antibody. Okay. Anti is against, body is the substance, so it's a substance that's produced in response to an antigen. In this case, it's a protein created by the body in response to a foreign pathogen. Humoral. Okay. Humor means fluid. Al means pertaining to. So it's a defense mechanism arising from antibodies or immunoproteins in the blood. Immune is to be protected from infectious disease. Immunity is a state of being protected. Immunology, the science and practice of immunity and allergy. Immunologist is a medical specialist in immunology. To immunize is to make resistant to an infection. We know, for example, that during a very early stage of their development, children are immunized against many childhood diseases. Okay, and that follows a process of actually immunization, I should say, the actual administration of an agent to provide immunity. We could also say that we are introducing immunoglobulins. They are specific proteins evoked by an antigen. Okay, all antibodies are immunoglobulins. For example, when I get immunized, I may have antibodies introduced into my body against a specific pathogen. Lymph is a fluid, and it comes from the Latin term meaning clear spring water, and it's a clear fluid collected from tissues and transported by lymph vessels to the venous circulation. Okay, ultimately, it's going to get dumped into the superior and inferior vena cava. Lymphatic is pertaining to lymph or the lymphatic system. Lymphocyte is a small white blood cell with a nucleus. Okay. Node. A node is a circumscribed mass of tissue. We think of a lymph node as a lymphatic tissue that, again, is going to be throughout the lymphatic system that filters lymph as it moves through those vessels. Parasite. Parasite is an organism that attaches itself and lives in or on and derives its nutrition from another species. It can't exist on its own. Pathogen, a disease-producing microorganism. Pollutant, a substance that makes an environment unclean or impure. Okay. Toxins. Toxin is Greek for poison, a poisonous substance formed by a cell or organism. Our cells, to protect us from pathogens, we have a type of cell called a cytotoxic T cell that's actually poison. It secretes a poison that destroys foreign pathogens. Toxic is an adjective form in this case, pertaining to a toxin or poisonous. And toxicity, okay, is a state of being poisonous. Well, continuing through the lymphatic system, we talked about how the lymph nodes are going to filter this fluid and, again, filter out foreign pathogens. Well, the filter traps the pathogens, and then it's up to specialized cells of the immune system to destroy whatever the pathogen is. And specific cells may be T lymphocytes, and the T stands for thymus, where they become mature. And we have 4 types of T lymphocytes. We have the cytotoxic T cells. They destroy pathogens by secreting a toxin to the pathogen. Helper T cells, just as the name implies, they call for help. When helper T cells encounter a foreign pathogen, they don't wait around. They call all of our defense cells to come and destroy this pathogen. Once they all get there, then they kind of decide who's best suited to do the job. Memory T cells. Just as the name implies, memory T cells will remember a foreign pathogen that tried to invade our body and make us sick, and years down the road, they will still be able to identify a foreign pathogen and destroy it before it has the opportunity to actually make us sick. Then suppressor T cells. Well, we don't want our immune system keyed up all the time, so just as the name implies, suppressor T cells of the lymphatic system and immune systems help to shut down our immune system. That way, we aren't wasting precious resources creating more and more of these special cells to ward off pathogens when there aren't any pathogens to ward off at this point. Then we get into B lymphocytes. They're not nearly as numerous. They only encompass about 25% of the total number of cells of our immune system. But B lymphocytes secrete antibodies. Antibodies are going to be immunoglobulin proteins. Okay, that's a whole mouthful, but basically they are specialized proteins specific to a given antigen that will ultimately destroy the antigen. Okay, we also have what are called null cells that are a type of lymphocyte, and they will destroy pathogens. They just have a little bit different way of doing it. They don't have quite the same means of killing the cells as, say, the B cells that secrete the antibodies, or say the cytotoxic T cells, but nevertheless they can destroy foreign invaders. Then we have macrophages. Macrophages develop from smaller cells called monocytes that develop in the blood, and ultimately macrophages are going to be like big Pac-Man cells. They are just going to simply follow around foreign pathogens and destroy them. Just like Pac-Man used to gobble up things on the screen on the Pac-Man video game, these macrophages chase down pathogens and they will engulf them. Some more specific terms associated with the lymphatic system. Okay. Coreceptor is a cell surface protein to enhance sensitivity of an antigen receptor. And basically what that is doing is just enhancing our immune system, okay, getting it peaked to a higher level when it's been exposed to some sort of a foreign invader. Okay, cytotoxic, an agent able to destroy cells. Follicle. We may hear the term follicle when we're talking about the hair in the integumentary system, but follicle can also pertain to the lymphatic system. A spherical mass of cells containing a cavity or a small cul-de-sac, such as a hair follicle in this case. Macrophage, a large white blood cell that removes bacteria, foreign particles, and dead cells. Null cells, lymphocytes with no surface markers. Okay, that's how they differentiate themselves from B cells and T cells. Phagocyte. Okay, phago or phago, P-H-A-G/O, means to swallow or engulf. So phagocytes are blood cells that ingest and destroy foreign particles in cells. Okay, phagocytize would be a verb form, which means the actual act of engulfing foreign particles. Phagocytosis, a process of ingestion and destruction of foreign particles in cells. Phagocytic, pertaining to phagocytes or phagocytosis. Okay, and then finally, plasma cells. Okay, plasma cells are derived from B lymphocytes and activate in formation of antibodies. B lymphocytes, they're going to actually differentiate into two types of cells of the immune system when they encounter a foreign invader. So B lymphocytes will differentiate into plasma cells, which create immunoglobulin proteins. They'll also differentiate into memory cells, which will remember a foreign invader for later, in case that same foreign invader tries to get us sick again down the road. Now, we talked about the spleen, moving on. Okay. And if we were to look at the spleen, like in figure 12.4 from the McGraw-Hill resource, and we can see that it's kind of wedged up underneath the diaphragm, and the diaphragm's cut away. We have a good look at the spleen. The spleen is going to contain red pulp and white pulp. And the white pulp is part of the immune system that produces T cells, B cells, and macrophages. Okay, the red pulp acts as a reservoir for erythrocytes, platelets, and macrophages. Okay, and as we said, that reservoir ultimately is where red blood cells go to die because they're going to be removed from circulation by the spleen. Okay. Tonsils. We talked about the tonsils a minute ago. Tonsils are going to be, if you look in your own oral cavity, you can see the tonsils. They're going to be in the back on the sides of the oral cavity. They protect us from any kind of pathogens trying to get in through the oral cavity, or of course when we bring things in through our nasal cavity as well. Okay, and the adenoids are very similar tissue to the tonsils, and they're in the posterior rear of the nasopharynx. So they're in the back upper part of the throat. Okay, the thymus gland, okay, is going to be where T lymphocytes mature. Okay, it's located in the thoracic cavity. Okay, and as I said before, it's going to actually get smaller as we age. Okay, some additional terms associated with the lymphatic system. Adenoids are masses of lymphoid tissue in the midline of the back of the throat. The spleen, a vascular lymphatic organ in the left upper quadrant of the abdomen. Okay, splenectomy, Spleno is a combining form that means spleen. So it's not spleen-ectomy, it's splenectomy. Splenectomy. Ectomy is a suffix which means surgical removal. So splenectomy, surgical removal of the spleen. Splenomegaly, not splenomegaly, but splenomegaly, enlargement of the spleen. Tonsils, tonsillo, okay, the combining form tonsillo, okay, is going to mean a mass of lymphoid tissue on either side of the throat at the back of the tongue. Tonsillectomy, tonsillo, is the combining form. Ectomy is going to be surgical removal, so surgical removal of the tonsils. Or tonsillitis, another term that means associated with the lymphatic system, that means inflammation of the tonsils. Now, disorders of the lymphatic system. Hodgkin lymphoma. Oma, we said, meant tumor or cancer. And Hodgkin lymphoma is going to produce a unique looking B cell. Of course, B cells are a type of lymphocyte. They're a type of white blood cell. And they have what are called the Reed-Sternberg cells. And they have, if we look on figure 12.6 in the McGraw-Hill resource, we can see a huge cell there in the middle, quite large compared to the other cells around it, that has a unique look to it. And that gives Hodgkin lymphoma its distinctive appearance. Now, non-Hodgkin lymphoma does occur more frequently than Hodgkin lymphoma, but it doesn't contain that large lymphocyte which is described as the Reed-Sternberg cell after the researchers that first found and described it. Tonsillitis, a common disorder of the lymphatic system. Splenomegaly, and as it says in the book, it's not necessarily a disease itself, but it's secondary to some sort of another disease process. Ruptured spleen, that can occur. Athletes in contact sports. I think Drew Bledsoe got hurt. A matter of fact, I think that may be how Tom Brady got to be the quarterback for the Patriots years ago. I think he got hit and actually had his spleen become injured, I think, if I remember right. And that's what ended up leading to Tom Brady being able to step in and be the quarterback for the Patriots. But you see this in car accidents as well, a ruptured spleen. Now, lymphedema. Lymphedema is going to be a localized, non-pitting fluid retention caused by a compromised lymphatic system. Usually you see it occurring after surgery or after radiation. Females, if they have one breast removed due to breast cancer, they also take out all the lymph nodes and those lymph vessels as well, and they may have very pronounced swelling in one of their arms due to all of the fluid accumulating in that area, and it can't be recirculated back to the heart of the cardiovascular system. Okay, so our terms associated with, continuing with our terms associated with the lymphatic system, we already talked about Hodgkin lymphoma. Hypersplenism, a condition in which the spleen removes blood components at an excessive rate. In this case, it takes out too many of the components of the red blood cell, too much of the heme and the globin, which comprise a large amount of the red blood cell. Inguinal, okay, inguino means groin, ale means pertaining to, so pertaining to the groin. Lymphadenectomy, and that is going to be a surgical excision of a lymph node. Lymphadenitis. Okay, now my tongue's starting to get tied. Inflammation of a lymph node. Okay, Lymph Adenopathy, any disease process affecting the lymph nodes. Lymphangiogram, a radiographic image of the lymph vessels and nodes following injection of contrast material. There they're going to put a radioactive dye into the system and track it on a fluoroscope, which is basically just an X-ray device, and they can see what is going on with the lymph nodes. Is there any abnormality? Lymphedema, we already talked about that. Lymphoma, any neoplasm of lymphatic tissue. And of course, neoplasms, there's a chapter devoted to neoplasms in ICD-10. And of course, a neoplasm is just going to be the formation of new tissue. And in the case of neoplasms, when we think of the formation of new tissue, that's going to be a rampant growth of cells that's uncontrollable. And we'll get into that in just one second when we get into cancer. Now, a few other terms associated with the lymphatic system. Antigens. Antigens are going to be markers. Imagine that every cell in Carrie Bernard's body has a marker that lets every other cell realize that it's one of my own cells. For example, we might say that every cell in Carrie Bernard's body, just to keep it easy, has a K marker. That's my antigen. That lets every cell in my body know that it belongs to Carrie Bernard. Here, we have a pathogen. If this pathogen comes into contact with another cell of my body, very quickly, my cells realize this does not look anything like that. This antigen is foreign. All Carrie Bernard cells should have this K antigen. And so when we see a cell that has a different antigen, ultimately our immune cells, B lymphocytes, T lymphocytes, they're going to attack that foreign invader and destroy it. So that's what we mean when we are talking about an antigen. It's a marker on a cell, and all of our cells have them. Autoimmune. Autoimmune. Okay, it's an immune reaction directed against a person's own tissues. We typically hear of autoimmune diseases when we think of rheumatoid arthritis or something like lupus. Our own immune cells destroy good cells. That's why I talked a little while ago about suppressor T cells turning off the immune response. We don't want an over-heightened immune response, because what the cells of the immune system end up doing, they go around looking for any cell that isn't perfect, and then they start to attack it. And in many cases, that would be our own cells, because they don't have anything better to do, so to say. Discrimination, the ability to distinguish between different things. Hapten, a small molecule that has to bind to a larger molecule to form an antigen. So it's part of the antigen complex. Mutation, a change in the chemistry of a gene. Okay, our genetic material is DNA, and that DNA is our blueprint that makes us who we are. Carrie Bernard could be remade, in theory at least, by taking DNA from a cheek cell. Ultimately, you should be able to reverse engineering wise create a new Carrie Bernard. They did that years ago with Dolly the sheep, for example. Well, a mutation is something which causes a change in a gene, and that ultimately leads to a cancer forming. Okay? They say that cancers are all genetic in one way, shape, or form. It's not necessarily that they are passed down from the parents to the offspring, but it's genetic in that our genes get altered by environmental factors or by poor living or whatever the case may be, which can ultimately cause cancer to occur. Resistance is the ability of an organism to withstand the effects of an antagonistic agent, meaning to withstand the effects of a pathogen. Specific is relating to a particular entity. Okay, an antibody is specific to a given antigen. Okay, so if we create antibodies in our system against a staph bacteria, it is only good against a staph bacteria. Those same antibodies won't be good against a streptococcus bacteria. Now, continuing with our immune system, hypersensitivity reactions. Hypersensitivity just simply means an allergic reaction. Okay, some people might have a hypersensitivity reaction to a new detergent, or maybe they'll have a hypersensitivity reaction to something out in the environment. But in many cases, it's going to be something which causes a reaction of the body in a way that's definitely not beneficial. An excessive hypersensitivity reaction will be anaphylaxis. Such an extreme response to something in the environment or something that a person comes into contact with that the person goes into respiratory distress, and then potentially could even go into respiratory arrest. Peanut allergies are something now that are very common, and in some cases can be to such an extreme that people will go into respiratory arrest and die from it. So again, that's a case of anaphylaxis. Asthma. Asthma is something probably a lot of people may have or know somebody that has asthma. And what are called triggers, okay, are just allergens which cause the body to respond in a way that causes smooth muscles of the airway passages to constrict, and that in turn doesn't allow the person to breathe properly. We have smooth muscle that surrounds all of our airway passages, and if that smooth muscle clamps down so tight that the airway passages are crimped off, well, then the person can't move atmospheric air into their air sacs of their lungs and get the oxygen out. They also can't get rid of carbon dioxide. Only if you can get that smooth muscle to relax does the airway passages open up to its normal diameter and allow air to move in and out. Now, we talked about autoimmune disorders. They could be things like rheumatoid arthritis. They could be things like lupus. All of those are going to be diseases in which our body's own immune cells destroy healthy cells. Immune deficiency disorders can be congenital. Okay, that means inherited, of course. They couldn't be a case of something that's acquired, like AIDS. Okay, AIDS, of course, occurs due to the human immunodeficiency virus. Okay, so that's an acquired condition. Okay, whereas an inherited condition or congenital condition would be something like lupus or rheumatoid arthritis. Okay. Continuing on with some more terms associated with the lymphatic system, an allergen. Okay, it's an antigen from someone else in the same species. Sometimes people will have to have tissues transplanted to help bolster their immune system or start it over again. And so an allergen is an antigen from somebody else in the same species. Allogenic is pertaining to an allergen. Allograft, a skin graft from another person or cadaver. People that get burned in extreme cases may have to have an allograft. And again, it's a skin graft from another person or cadaver. Alloimmune is a reaction directed against foreign tissue. Anytime I have foreign tissue placed inside of my body or on my body, it's grafted on there, there is the chance that it could be rejected. The heart that could be potentially saving my life because it's transplanted into my body, I could ultimately form a reaction against it and destroy it. Anaphylaxis, we already talked about, immediate severe allergic response. Anaphylactic, pertaining to anaphylaxis. Histamine. Histamine is a compound liberated in tissues as a result of injury or an allergic reaction. We often hear the term antihistamine. A medication like Benadryl is an antihistamine. And again, it's to counter chemicals released from tissues due to injury or an allergic response. Antihistamine is a drug used to treat allergic symptoms because of its action is antagonistic to the histamine, so it's an antihistamine. Hypersensitivity, exaggerated abnormal reaction to an allergen. Immunodeficiency, failure of the immune system. Years ago, when I was growing up, I remember watching the Saturday morning cartoons, and they would have little news briefs in there, and they talked about David Vedder, the Bubble Boy. And he was confined for the 12 years of his life from 1971 to 1984 to living in a protective bubble because he had what was called severe combined immune deficiency, and he had no immune system. So in that case, it was an extreme situation of literally no immune system that he was born with, whereas HIV, people, when they have HIV materialize as full-blown AIDS, would lose all of their immune function, but again, it's acquired. Immunosuppression, suppression of the immune system. Maybe somebody who has an organ transplant has to go on immunosuppression the rest of their life. Okay. Transplant, the tissue or organ used or the act of transferring tissue from one person to another. Maybe it's something as large as a heart, or maybe it's just something like the cornea of the eye. Transplantation, moving of the tissue or organ from one person to another. And then urticaria. Urticaria is going to be a rash of itchy wheals or hives. So people typically call urticaria, they just simply call them hives. And we've probably all seen that, maybe as a response to grass or something along those lines. Now, we've already talked about AIDS to some extent, and AIDS is going to be related to the human immunodeficiency virus. And the reason AIDS is so devastating is that it destroys our helper T cells. And as I said a minute ago, the helper T cells live up to their name. When they encounter a foreign pathogen, they just say, hey, help, come over here. I need all of my immune cells to congregate here. We'll decide later who's best suited to destroy this foreign invader. When you wipe out somebody's helper T cells, you diminish their ability to ward off any type of pathogens. So it's not that somebody dies from AIDS, it's they get an opportunistic infection and they die from something like toxoplasmosis, which is a parasite that's often found in undercooked meat or in cat feces, or they die from cytomegalovirus. Again, it's related to the herpes virus. It's something that really we're all exposed to and have it for all of our lives, but it doesn't manifest unless we have a very weakened immune system. A bunch of other things like pneumocystis pneumonia, that's another disease which is opportunistic that often kills patients that have AIDS. So all of those are opportunistic infections, opportunistic pathogens that kill somebody with AIDS. It's not the virus itself that's deadly. It's the fact that the immune system gets so weakened because there's no helper T cells available and the immune system can't ward off any kind of foreign pathogens. And as we continue to learn more terms associated with the immune system, dormant means inactive. Incubation, the process to develop an infection. Kaposi sarcoma, that's going to be one of the main signs of somebody having HIV. Lavage is the washing out of a hollow cavity, tube, or organ. Somebody that has a septic infection where their entire system has this infection, they may have to have a lavage performed on, say, their internal organs. Opportunistic, an organism or disease that is a host with lowered resistance. Retrovirus, a virus that replicates in a host cell by converting, that's Janice trying to log in through my Skype account. Hopefully she can log in and see what we're doing, or at least talk to us about it. But a retrovirus actually uses our own genetic material to replicate itself and flourish. And that's actually how AIDS destroys the helper T cells. It will invade our body's helper T cells and literally use the helper T cells to replenish itself. And then it proliferates in such vast numbers that it leads to all of the helper T cells being wiped out. Virus, okay, a group of infectious agents that require living cells for growth and reproduction. And then viral, pertaining to or caused by a virus. Okay, viruses can't stand on their own. They have to have a susceptible host to be able to flourish, or they'll perish. Okay, does anybody have any questions on chapter 12? That was the lymphatic and immune systems. And I want to go ahead and get into the next chapter, which deals with cancer, here in just a minute. But again, if anybody has any questions, please feel free to fire away.